If you jumped out and aimed for a giant trampoline, you might think it would bounce you hundreds of feet back up into the air.
No, I wouldn't, Zach. When jumping from the plane, there are two forces acting on the person. A down force due to gravity and an up force because of air resistance. Net of these two is mass times the rate of change of velocity, or mass times acceleration. At terminal velocity, this rate of change is equal to 0, meaning mass times gravity is equal to 0.5 times air density times the drag coefficient times the downward facing area of the person times terminal velocity to the power of 2. Doing some simple math, we can calculate the terminal velocity to be the square root of 2 times mg divided by rho cdA. Let's assume an 80 kilogram person with an air density of 1.2 kilograms per meters cubed, drag coefficient of 1, and an area of 0.7 meters squared. That means the terminal velocity of the person falling down is 43 meters per second, or 155 kilometers per hour, 96 miles per hour. The kinetic energy the person has at impact is 0.5 times his mass times this terminal velocity to the power of 2, or 74,743 joules. The trampoline acts like a spring, and the spring constant depends on how it was built. For a giant trampoline, we have a spring constant of 400 newtons per meter, all the way up to 20,000 newtons per meter for custom built ones. The energy stored in the trampoline is 0.5 times this constant times the amount of sag under it to the power of 2. This means the sag is the square root of 2 times the energy divided by the spring constant. For a custom trampoline, the sag is 2.7 meters with a peak force of 55,000 newtons. Divided by mass times gravity, and you get almost 70 g, which means the person won't survive the impact. For a giant trampoline, you get a 20 meter sag with 10 g, which is also impossible. And according to membrane theory, the tension would be 4 times the radius of the trampoline divided by 4 times sag, which is 2,000 newtons per meter, which is also impossible because the sheet would fold like a parachute with a slight breeze of 15 meters per second. So no, I don't think if I jumped the trampoline it would bounce me hundreds of feet into the air, Zach. I would think there is no way I would survive it. Love you.